In today's lesson, we're going to look at the concept of formula mass and molar mass. Basically, when it comes down to it, formula mass is the mass of a chemical formula. For example, if we have here calcium hydroxide, we see that calcium hydroxide is made of calcium ions and hydroxide ions in the ratio of 1 calcium ion to 2 hydroxide ions. Now, what we are saying here is that if we're going to calculate the formula mass is actually how heavy this molecule would weigh. So in order to do that, what we could do is go over to the periodic table, and I've pulled a few blocks from the periodic table over here on the left-hand side. We see we have calcium, oxygen, and hydrogen. According to their locations on the periodic table, they have atomic masses of 40.08, 15.99, and 1.0079. Now we're going to round these to whole numbers for simplicity's sake. Now, in this particular formula, if we were to count up the atoms involved, we see that we have 1 calcium, 2 oxygens, and 2 hydrogens. So I've drawn these molecules over here on the side. Now if I were to take these molecules and place them on this imaginary bathroom scale and weigh them out, well, we would assume that they would weigh the mass of every single one of these atoms. Now what we're going to do right now is we're going to show you how you can calculate this concept. Okay, to calculate the formula mass of a compound, what we need to do first is recognize what the formula is, and we've already written it. It's CaOH2. Now what that means then is that in this compound we have a calcium, and in terms of atoms, we have 1 calcium atom. And that calcium atom weighs 40 AMUs, meaning that in this formula there are 40 AMUs, or 40 atomic mass units, which is the unit for formula mass in calcium. We also have 2 oxygen atoms, each weighing 16 AMUs, giving a total of 32 AMUs worth of mass to the formula. And hydrogen, there are 1 of them, each weighing 1 AMU. Oops, sorry, there are 2 of them, sorry, each weighing 1 AMU, giving us a total of 2 AMUs. Now if we take this total mass of the formula, this would give us 74 AMUs. And that would be the weight of 1 of these particles. Now, the problem is that in the real chemistry world, weighing out just 1 atom or 1 molecule is just not that convenient. So what we do instead is that we want to figure out how much a grouping of them would be. And that's known as the molar mass. And to convert to the molar mass, it's very, very simple. All you need to do is that you turn the AMUs into a more usable measurement, which is grams, and we say that that's equivalent to 1 mole worth of particles. So what we're looking at here is, this is the formula mass, and this would be called the molar mass. So they're calculated in the same way, except for the formula mass is in terms of 1 particle, whereas the molar mass is a whole group of particles, which we'll explain in a later lesson.